Hello, my name is Daniel Nenny, and I'm the founder of SemiWiki, the open forum for semiconductor professionals. Since going online in 2011, SemiWiki.com has registered more than 200,000 active members. If you're not a member of the SemiWiki community, please register as my guest. I hope to see you there. Today's webinar is titled, Leverage Certified RISC-V IP to Craft ASIL ISO 26262 Grade Automotive Chips. The speakers today are Marvin Chao, Andes Technology Director of Solution Architecture, and Chuck Brokish, Green Hills Software Director of Automotive Business Development. If you have questions, please put them in the chat box and we'll answer them during the Q&A. Okay, let's get started. Over to you, Marvin.
Thank you for the introduction. And so for today's session, I want to talk about the collaboration that Andes is having with our partner Green Hills to deliver a RISC-V functional safety solution to the industry. So first, when we look at what happened in the automotive industry today, that we can see the industry is undergoing a revolution right now. And there are several different driving forces that is changing the landscape of the industry. For example, that the industry is having the electrification, that the new energy vehicle is rapidly replacing the gasoline cars driving on the street. And at the same time, we can also see the cars getting smarter and smarter these days, that the ADAS system in the modern car today start to become a major point of differentiation for the new car buyers. And when we look at the software-defined vehicles as well as the drive-by-wire technologies, that we can see that this is also fundamentally changed the dynamics for a vehicle. So the concept of a new car is no longer limited by during the time when the cars is getting designed and manufactured, but also that after you ship your car to the hands of your customers, the car manufacturer can still push through over-the-air software and the firmware update and change the concept of the car afterwards. And that the vehicle is getting connected to the world these days. The V2X represents the vehicle to everything, that you have different services on the cars, all the way from the GPS connections to the emergency roadside services, as well as for your ADAS system, that you will still need the connection to get a high definition map just to keep the ADAS system to keep the car in between lanes. And we see also change here that we reach a conclusion that more and more processor is needed in today's automotive world. And with those additional processors, that functional safety is more important than ever. So now let's just take a look at the functional safety development. There are some of the common components in the structure when you want to develop a functional safety solution. Usually when you start a project, you want to identify and define the assumption of use of your design as well as the safety requirements. For example, you have to perform the hazard analysis. The HARA is one of the standard components when you first start your design. Most of the IP providers, they will choose to start with the out-of-context methodologies. And if you're the IP integrators, things important for you is the scope of the functional safety evaluation. So this is beyond just the ASIL B or ASIL D compliances, but also you have to understand what exactly is getting included in those evaluations. And other things that's important for the IP integrators, including how you want to configure your processor cores. For example, ASIL B or ASIL D, that you have to configure the core differently in order to reach those safety standards. And for the integration, that you also have to understand that what kind of safety mechanism, what kind of signal you connect it to your systems. And we talk about the safety mechanisms. This is important for the safety design. The safety mechanisms used for the fault detection and the control mechanisms. Typically, there's two different kinds of safety mechanisms. There's the internal safety mechanism and the external safety mechanisms. Internally, safety mechanisms are used by the IP design itself to detect the exceptions and to correct all the problems. And the internal safety mechanism is important for the IP integrators because you want to know what kind of signal or the information you can get from the IP design, so you can implement the safety concept on the system level. Just use an example from the Andes design that in all the CPU core we provide to our customers, we offer the course track status bus interface. So at the system level, you can constantly track the status of the processes. Another important concept for the safety design is the fault tolerant time interval. And this time defines the maximum allowed time between when the incident happens and when you're designed back to the safe state. And this is a very important concept for the safety design. And one another important component for the safety design is the safety analysis. And this is the cornerstone for when you want to create a safety design, that in ISO 26262, it requires you to perform a comprehensive safety analysis for your design to make sure that you have enough diagnostic coverage for all the exceptions, and the residual fault in your design is sufficiently low to meet the requirement for different ASIL level. For example, that you can see the table on the right side, that this is a famous table to define the requirement for different type of failure mode. You have the single point failure mode, and you have the multi-point latent fault matrix, and as well as the probabilistic matrix for the Rittenhauer fault. All those metrics that you have to provide the evidence to the integrators that with all different kinds of failure that you can reach either the ASIL B or C or D, the requirement in each of the level. And another thing you have to provide the evidence in your safety analysis is that you want to make sure that in your design, you can provide the independence as well as freedom from interference in your design. So this is where the dependent failure analysis and the fault tree analysis comes in through inductive and the deductive analysis, that you can provide this evidence in those reports to show to the IP integrator that you do have those design goals in your IP design. Now let's take a look at some of the applications for different functional safety level. For the ASIL B application, that we can see there are several different use cases from inside the vehicle to outside the vehicle. For example, inside the cabin of your car, you have the in-car monitoring system to keep track the status for the driver as well as the occupant. The touch and display controller is important for the infotainment system in the car these days. And these days, we all have a digital cockpit in our cars. This makes the in-car storage to be more important, and it requires the storage to be more reliable. And outside the car, there's various different ADAS features that will also need to meet the requirement for the ASIL B. For example, there's automatic high beam control and the blind spot monitoring, adaptive cruise control. They are all important for the intuitive for the ADAS systems. And all the cars these days ship with a variety of different number of the CMOS sensor. And those sensors will also be another example for the ASIL B application. And another level of the safety requirement is the ASIL D application. This is typically for the application that has a very immediate and direct impact on the safety of the driver and the occupants. Some of the examples you can see here is from the electronic power steering system, the engine management system, the electronic stability control, as well as when it comes to the EV, that you typically have the battery management system, as well as the motor control. And for all those applications that the safety requirement is to the highest level for the ASIL D, because the tolerance in the allowed residual for those applications are usually pretty low. So on this slide, that I want to show that what is the typical methodology when we come to the ISO 26262. That typically, when you look at the requirement on the 26262, it primarily handles the safety from two different aspects. one part of the failure is the systematic fault. And for this systematic fault, it is usually, it can be triggered deterministically if it can reproduce the conditions. And this type of fault is typically caused by either the design errors or the software errors. And this is why that usually the requirement is to deploy a more rigorous development process. And another type of fault that 26262 is trying to manage is the random fault. The random fault can happen unpredictably. So for that reason, that it is very hard to totally prevent this from happening. So for the random fault, the techniques that we use is by implementing the safety mechanism, so we can detect when those type of fault happens, and then we can perform the recovery for those faults that make our design back to a safe state. And with those two different types of methods together, we can make our design to reach various different levels of functional safety standard. So what I want to show you here is an example of how Andes provides an evidence for managing those two different types of hardware faults in our design. On the left side, you can see that this is a development process certification, and this certifies that the development process at Andes is qualified for up to ASIL D development. And on the right side, that's the product certification for our industrial first RISC-V ASIL B processors, the N25F-SE, that we provide sufficient evidence to prove that we can reach the ASIL B requirement. So with those two certificates together, it essentially provides approval for the product itself to be used to further develop for the functional safety application. And what you're seeing in this slide is the Andes functional safety processor roadmap that we provide to our customers. On the left side, there's two processors, the N25F-SE and the D25F-SE. Those two processors are what we call the mainstream processing. They are 5-stage single-issue processors. Both of them are targeted for the ASIL B applications. And moving forward in 2024, Andes is looking to provide two additional designs to its customers. The first safety core that will come available is the D45SE. For this course, we plan to deliver additional performance as well as the additional safety level for the mission critical applications. And in the second half of 2024, we are going to provide the second safety core to our customer, which is going to be focused on the power efficiency as well as the additional safety features. And this is the D23SE core. And further into 2025, Andes plan to provide yet an additional high performance course for some of the typical automotive applications, such as the ADAS system and the infotainment systems. Worth noting that this core is, for this course, this is the application processors that typically can run a feature-rich operating system such as Linux and Android. So let's take a look at some of the high-level features for some of those cores we just talked about. First, let's take a look at the N25F-SE and the D25F-SE. These two cores are designed to be simple and effective. The two cores are 5-stage in-order single-issue processors. They are the 32-bit RISC-V architectures. For the instruction set, it supports the GCBP. For the P extension, this is a DSP extension that will allow the user to implement various different type of DSP algorithm and accelerate their algorithm on the D25F-SE. And for the B extension, this provides an additional bit manipulation support. And this is useful for some of the applications such as the cryptography. And when it comes to the memory systems, that these two cores will allow the user to configure with various different levels of cache as well as the local memory for both instruction and the data. For the bus interface and the system integration, that there's two cores that supports the common bus interface, including the A side and the HB. And if you do choose to configure with the local memory on this course, we also provide an additional direct access port so you can share the memory with the rest of the systems. And when it comes to functional safety, those cores provide a variety of different safety mechanisms to protect the design. The core traps bus interface is something that we mentioned that you can use to track the status of the CPU. All the memory on those cores are well protected through ECC and the standard RISC-V physical memory protections. And we also provide an additional protection for the stack overflow. These two cores are already available for the customer to license. And right now that the D25F-SE is at the final stage of the certification process, and it is expected to be fully ready before the end of the year. Now let's talk a little bit about the other cores that we're currently working on right now, which is the D45SE. And this core is targeted for the ASIL D applications. The core provides A-stage in-order dual-issue architectures, similar to the 25 series core we talked about previously. That this is also a 32-bit processor that will provide a similar type of instruction support for the GCBT. For the memory systems, this is also similar to the N25F-SE and the D25F-SE that you can configure both cache and the local memory for different kind of use. One of the key improvements in this area is that we provide a technology we call MEMBoost that will effectively increase the memory transaction efficiency to about 2 to 3 times improvement. And this improvement is matched with the additional compute throughput we have on this core perfectly, that essentially you can run a higher performance application on the D45SE. And this is an ASIL D CPU core, which means that when it comes to functional safety, we will provide the dual core lockstep mechanisms that essentially this is a common approach to reach a higher level of diagnostic coverage and lower down the residual fault on this design. That other safety mechanism we provide on this core is also similar to the 25 series core, that we provide the protection on all the memory we use on the CPU, and as well as the core trap status bus interface. And one thing to note is that for this core, we provide an additional protection on the bus transaction, and this is provided only for the ASIL D design. And right now that we're looking to have the ASIL D certification to be ready somewhere around the first half of the 2024. So I want to spend a moment to talk about the Andes technology, which is a great company who provides this functional safety portfolios. The Andes technology is a pure play CPU IP vendors that we have been founded in Taiwan somewhere around 2005. So this year that is our 18 years. Well, it's 18 years of the company. We're public companies, and we are taking a very active position for making the contribution to the open source communities. And also that the Andes technology is one of the founding members for the RISC-V International. Our senior management, including our CEO and the CTO, are taking a very key roles in some of the key activities for the RISC-V International. And as well as that, we're also making active contribution in various different task force, including the DSP task force, the trust execution, as well as the fast interrupt. Some of the quick facts for the Andes technology, that right now, our CPU core, the RISC-V CPU core is our 5th generation architectures. The company is highly technically oriented. Globally, we have around 450 employees, and among all of our employees, 80% of our staff is on some type of research and development role. Globally, we have more than 300 licenses, and something that many people doesn't know about the company is that by 2023, that we already have about 12 billion devices that's shipping to the market that has the Andes processor on it. So here I want to talk about the collaboration efforts that we're making with, we're working together with with our ecosystem partners. That in order to provide a safety design to our customers, it has to be more work than just the hardware CPU design that we provide to our customer, but also that there's other part of the equations. For example, that there's several of the key areas that we're actively seeking to build a partnership with the ecosystem providers. For example, there's a security which becomes more and more important today. And the safety RTOS is a very key part of the equation to reach the safety on the software side. And for the auto side, it defines the standard software interface. So your design, you can easily port your design to different hardware environments. And for the development for the functional safety, that you also need support for the tools, including the compilers and debuggers. And this is why that at Andes, we feel great honored to work together with Green Hills to deliver a holistic to take this a holistic approach to deliver our solutions to our partners. So I want to take a stop here, and I want to hand over to Chao from Green Hills to talk about the amazing work that they have created for the customer.
My name is Chuck Brookish, and I am the Director of Automotive Business Development for Green Hills Software. Thank you for joining. Fantastic introduction by Marvin on the hardware side. It takes hardware and software to make a truly safe system. So Marvin covered the hardware side. I will go ahead and cover the software side here. So for those of you who may not be familiar with Green Hills Software, we've been around for over 40 years. We have expertise in embedded software. Specifically, we focus on critical systems, systems in which software failure is simply not an option. Within those markets, our tools and software are certified at the highest levels of safety and security for every market. Those markets include military aerospace, industrial, rail, medical, and of course, automotive, where I tend to focus much of my time. While RISC-V might be new market space for many, we are not new to this space, as we've been working on RISC-V since 2018. Green Hills actually started as a compiler company, but our product line, including products supporting RISC-V, go well beyond the compiler. We have a full suite of integrated development environment tools called Multi, which support the simulator, prototype devices such as FPGA, and of course, target SoCs. We have JTAG probes and high-speed trace hardware, enabling debug of complex multi-core devices. And we have security and safety certified real-time operating systems available for both microcontroller designs as well as complex microprocessors with MMUs that are focused on high-end applications. You can see here the listed devices which we already have support for within Andes' product portfolio. Here's a suite of tools available for RISC-V and the current support for AndesCores. We're excited about this capability and ready to engage with Andes partners for development on AndesCores. As stated earlier, we've been working with RISC-V since 2018. You can see here the continuous development and addition of capabilities that we've been adding over the past 6 years. One could say that we've been preparing for RISC-V for the last 40 years. If you look at the various CPUs and device families that we've supported with our compiler, you'll see that we've developed expertise on CPUs from simple RISC cores to complex CISC and DSP cores over a variety of industries and applications that have enabled exposure to system needs and applications that span the gamut. This experience and exposure has enabled us to create a compiler that creates the fastest code with the smallest footprint for almost any application you can put in front of it. We continue to be the benchmark by which much of the industry measures itself for code performance. So while RISC-V devices will ultimately have different architectures based on the individual IP provider, our compiler will continue to provide the best performance across those architectures, regardless of the specific architecture, as we've seen such architectures in the past. This long history of exposure and expertise across devices and industries has led to embedded software expertise that cannot be matched by anyone else in the industry. In fact, no other vendor has been independently certified to meet all these levels of security, reliability, and safety. Our development tools are safety qualified, meaning that they are qualified tools to create safety certified applications. Our operating systems, board support packages, and safety libraries are certified as safety elements out of context. This enables you to develop your own applications on top of the RTOS and using the tools and ease the process of certification of your final product, because the tools and components on which you've based your system are already safety certified. In addition to the tools and base level software, we provide expertise and guidance to our customers through such offerings as safety manuals, workshops, and services to work with our customers to get their products through certification and shipping into these critical industries. So let's go back to the compiler, as most of your development is likely to start with creating the code to operate on your newly selected RISC-V architecture. Green Hills Software has been creating optimizing compilers since 1982 for a wide variety of products across a vast array of architectures and for a broad range of industries. This has led to a compiler that enables maximum performance with a minimal footprint. Because we cater to software critical industries, our compiler has always focused on ensuring that the code operates correctly and without vulnerabilities. The compiler itself goes through almost 4 million test vectors each night to ensure that we are always meeting those requirements around performance, safety, security, and reliability. While you may still be deciding what base level capabilities as well as extensions you will utilize within the RISC-V architectures and extensions, we have been working to include all of the capabilities. You see here that we support all of the baseline instructions as well as all of the extensions for 32-bit as well as 64-bit RISC architectures. And we realize that some customers may leverage the option to create their own custom RISC-V instructions. So we've enabled a couple ways to incorporate those instructions into the compiler. Those instructions can be added to the toolchain by Green Hills, enabling optimization to include your custom instructions, or you can add the new assembly instructions via configuration files. Either method allows you to add the custom instructions to the compiler and have them supported by the assembler, debugger, and simulator. In addition, we also realize the hardware debug capabilities will differ depending on your specific implementation of the RISC-V architecture. Therefore, we've added support for multiple debug and trace mechanisms, including CoreSight, Nexus-based trace and debug, ntrace, and etrace. Back on the custom assembly instructions, here's an example of how your custom assembly instructions can be added to the RISC-V core and supported by the compiler and development tools. Whether we include the instructions explicitly within the tools or you add them via a configuration file, you can create code that includes these instructions and allows you to see that code within your disassembly of the multi-integrated debugging environment while debugging the end applications. You can see here a snapshot of code compiler results taken across a variety of benchmarks. The performance and code size for these benchmarks, as well as many others, is continually being improved through nightly regression tests comprised not only of standard benchmarks, but also customer-specific applications. Of course, the best benchmarks are your benchmarks, and we welcome the opportunity to work with you on your specific applications and help you to understand what optimization switches offer the best results for your applications. While ordinary development tools can compile and debug code, advanced development tools do that and much more. Advanced tools create code that runs faster, using less memory, produces high-quality code for those critical applications, make sure to meet industry standards for safety and security, and reduce time to find difficult bugs within your code. We've all been through the typical software development cycle of developing code, spending an inordinate amount of time finding the bugs, and then finally fixing those bugs. With advanced debug tools, capability of Green Hills that we will discuss throughout the next few slides, the time required to find the bugs is significantly reduced. And in turn, the time spent fixing bugs is reduced as well, because many of the bugs were avoided in the first place. In fact, the fastest way to avoid bugs is to ensure that they are not introduced in the first place. We have many tools at your availability to ensure that your code is not only optimized, but also avoids introduction of bugs which delay your development. Such tools include comprehensive compiler warnings, adherence to coding standards such as MISRA and other industry standards, static code analysis, runtime error checking, and assertions to force known capabilities and limitations within your system. The multi-integrated debugging environment brings all of these capabilities into a common user interface that allows your development team to use the same tools, regardless of whether they are working on simulator, emulator, or end silicon. Starting with certified libraries and optimizing compilers, and able to support multi-core heterogeneous architectures, the debugger is OS agnostic while enabling advanced debug through OS awareness of many standard operating systems. Debugging code gets simplified through advanced visualization of tasks and interactions of the various cores and operating systems. The resources saved by using such advanced tools enables you to save money, save time, and get your product to market faster with higher quality and reliability. We have the ability to support multi-core development and debug across heterogeneous cores, various operating systems, and end applications, all through a common single user interface. This can be done from initial development of code on a simulator, through silicon bring up on bare metal JTAG debug, or application level debugging using full system trace. Advanced debug capabilities such as history and time machine offer the ability to view timing and dependencies of software across the system and give you the ability to not only debug at various levels of C code or assembly, but also go back in time when there's a question of what happened in the code and why. This phenomenal capability enables your debugger to act like a DVR in that you can go forward, backward, and step frame by frame through your application to better understand what is going on in each subsystem and how it affects the other components within the system. Furthermore, Debug Snapshot allows you to save all of that information, share it across global development teams, and enable everyone to see the same issue, recreate the scenario, and get to the bottom of what would otherwise be impossible to find bugs within minutes or hours instead of days or even months. We have systems running today that leverage the Certified Integrity Real-Time Operating System for safety and security critical applications running on RISC-V architectures, enabling proven separation of applications and ensuring freedom from interference. This solution offers not only separation and freedom from interference for the critical applications, but also for the non-critical applications, including high-level operating systems. For simpler architectures which do not include an MMU, but are focused on the microcontroller space, we have the Microvelocity Real-Time Operating System, which also meets the safety certification for these critical environments, but also fits within the space constraints of smaller systems with less memory and CPU cycles available. The Microvelocity RTOS supports devices that include memory protection units as well as those without MPU, or in the case of RISC-V, I believe this is called PMP for the physical memory protection. There are lots of components that, I apologize. There are lots of components here that go into such complex system development. Many of these components come from Green Hills software, but we also enable utilization of the ecosystem for various middleware components and enable customer applications to be developed on top of all of this safety certified foundation. In summary, Green Hills Software has over 40 years of established pedigree in embedded software expertise, focusing on reliable, secure, and safety critical applications. RISC-V is a growing space within embedded processors, but is not new to Green Hills, as we've been one of the pioneers in this space over the past several years for compilers, debuggers, and real-time operating systems. As such, we offer RTOSes which support 32-bit as well as 64-bit architectures, support the simpler microcontroller architectures as well as the more complex application processors. We have global operations and work with OEMs, tier ones, tier twos, and ecosystem partners to deliver truly safe and secure solutions for the most critical applications in the world. Thank you for joining me today, and I'd be glad to answer any questions you have during our Q&A session, as well as offline. My contact information is shown here if you'd like to follow up with me later.
Thank you, Chuck. So first question for you, Marvin, is in regard to ASIL certifications. And, there's two certifications, ASIL ready and ASIL compliant. If you can tell us what Andes CPU certification is and maybe explain the difference between the two for the people that are not fully informed, like myself.
Yeah. Thank you, Daniel. So this is a great question that we are asked by our customer very often about these two differences. An easier way to explain this is for the ASIL ready certificate. This is essentially from our, for example, from our auditors, they describe the ready certificate as an early stage assessment for the safety measure and as well as the suitability of the design. The evaluation itself is on the high level that the primary focus for the ASIL ready certificate is primarily focused on some of the key safety analysis. For example, we talk about the FMEA and the FMEA here, that this is typically the only requirement for the ASIL ready certificate. And compared to this, the second type of ASIL certificate is the ASIL compliance certificate. For this, that it really has to go all the way into evaluating the compliances on every aspect of the development process. For example, there are several different sessions, all the way from the safety management to the system development, software and hardware development. So in order to get a compliance certificate, that the audition is really going through every aspect of the design to make sure that your design is fully compliant to the requirement made by ISO 26262. So I would describe that as a primary difference, is that the compliance certificate is really proof that the design itself has the full conformity of the 26262.
Question for you, Chuck. Is the Greenhill support for RISC-V specific to certain application types like automotive or medical?
Good question, thank you. Greenhill solutions are focused on applications that require one or all of these critical requirements for safety, security, programmer productivity. Our certifications are in popular embedded functional safety and security standards. As you saw on some of the earlier slides, we are in many industries, so it certainly goes beyond automotive and medical.
Okay, another question. Does Andes provide coverage report that gets to 90% SPFM and 60% LFM for ASIL-B for the core?
Yes, absolutely. So this is actually the key part to prove to your customer that in your design that you can fully reach all the requirements for different level of the ASIL requirements. So this is part of our standard deliverables that when you take the IP design from Andes Technologies, that we will also provide a variety of different safety analysis reports to our customers. So this is important for our customers in a way that what they have to do is they have to take those safety analysis to further prove to the conformers on the system level that they do reach either ASIL-B or ASIL-D level safety. So definitely that this is the key part of the value we provide to our customer.
Okay, I noticed that AutoSAR is listed as part of the presentations. Does Greenhill Software provide AutoSAR solutions?
Oh, that is a great question. Thank you. We are not AutoSAR vendors, but I would word it more as AutoSAR enablers. Greenhill's enables support to run AutoSAR or even multiple instantiations of AutoSAR as native applications within our Integrity operating system. This includes not only classic AUTOSAR, but also adaptive AUTOSAR. We can furthermore support AUTOSAR running within the hypervisor extensions of some of the modern MCU designs. And we even have partners in addition who work with microvelocity to use microvelocity as the RTE scheduler within AUTOSAR. So we have many ways of enabling AUTOSAR as we work with several of the AUTOSAR partners in the industry.
Okay. Another question from the same member. Can you explain what is a core trap and why is this relevant to functional safety?
Yeah, that's a great question. So for the core trap status bus interface, that essentially what it did is that every time when your core has an event like it has exceptions for various different reasons, or maybe you have a stack overflow or various different safety related event, that it will send those information to this core trap status bus interface that on the system level, you can always query through this interface to know that what is going on with the CPU cores. So this is one of the safety mechanisms that essentially we identify as a key safety mechanism as we can provide to our customer on the system level. So you always have a track of what is going on the CPU.
Okay, another question. Is hypervisor necessary to isolate critical software from non-critical software?
That's a good question. Hypervisor is not necessary to isolate the software, but a separation kernel, RTOS like integrity, is required for mixed criticality. Hypervisors enable the running of guest operating systems. If the integrity multivisor is used, then you get the best of both worlds. Native integrity tasks running in partitions and the guest operating systems running in partitions, both safely and securely separated by the integrity separation kernel.
Another question, can single core configuration of ASIL D processor, this has no dual core lockstep, can it be used for developing ASIL B applications?
Yeah, this is another great example that we get a question like this from many of our customers very frequently. So the quick question is yes, that essentially how this works is that for the ASIL D design, that typically, like what I mentioned earlier, that most of the IP vendor will create the dual core lockstep mechanisms, but you can configure the core with just a single core configurations. And with single core configurations, what we usually provide to our customers, we will also provide a similar type of safety analysis to show to our customers that with the single core configuration, what kind of the safety mechanism as well as various different powerful metrics we have with just a single core with just single core configurations. So similar to the ASIL B application I just talked about earlier, that if you're on the system side, you can take that as a supporting evidence to support your implementation to achieve the safety concept that you have on the system level. So yes, you can definitely use configure the code with single core and support that for the ASIL B development.
So where is Green Hill seeing RISC-V being used today?
We see RISC-V IP used as both accelerators and CPUs in SoCs addressing all kinds of embedded markets, frankly, from storage, space, to general purpose processing, to purpose-built automotive functions, as we're focusing on for this webinar today.
Okay. One last question for you, Marvin. What are the ISO 26262 coverage for Andes product certification?
Yeah, so this question is also similar to what we just discussed about the ASIL RISC-V and the ASIL compliances. That I'll just use this as an example. As many of the ASIL RISC-V certificate, what you can see is that they only cover section like I think it's section 5, clause 8, which simply just requires you to provide some of the key information about from your safety analysis for the coverage for the safety for the ASIL compliances. That essentially the coverage we have includes many sections in 26262. So this will include the safety management, as example, and we also have coverage on the product development on the system side, as well as the hardware side. And there's other requirements like supporting processes and the safety analysis that our author working with us to make sure that we address all the applicable sections on 26262. So this is why I mentioned that earlier, that with the ASIL compliances, this is really ensures that the full conformity of the design to a specific ASIL standard.
Thank you, Marvin and Chuck, for the great presentations. And thank you, everyone, for participating in the SemiWiki webinar series, and have a good day.